Hello and welcome, and in this video we're going to discuss the 10 worst programming habits you can have. Okay, so 1. Accepting code just because it works. This is number 1 on the list because it's definitely the worst thing you can do as a programmer. Code has to be written properly. I understand that's very difficult to do when you are in a company because there's deadlines that you have to meet, and sometimes you need to just release it anyway. But you should always strive to write the best code possible. Just because it works does not mean it's right. Write code properly, because if you don't, later on it's going to be a lot harder when you introduce a load of bugs because you didn't write it properly the first time round. Number 2 is over-commenting. I can't stress this enough. You should not comment every line of your code. That does not make sense. Good code should be self-readable. And by over-commenting, you make it very difficult to read and understand, right? Clean code should be easy to read without comments, right? You should have comments at the top of your function or method prototypes, right? But you should not use as many comments in the actual function scope, the body of the function. The only time you should be using comments there is when you're doing something that's quite complicated and it's not straightforward from the naked eye, right? Good code should be easily readable. So if it's easily readable, you don't need as many comments, right? If you're over commenting, there's a problem in your design. Okay, number 3 on the list is that you can't type very fast. If you can't type very fast, you can't solve problems quicker. When you first learn to program, you're going to be making a lot of mistakes. If you can type really quick, you can learn a lot faster. Now, naturally, when you've been programming for a long time, you actually learn how to type fast, right? So I think that not being able to type very fast is definitely a bad programmer trait. Now, I suggest you try to get your typing speed as at least 70 words per minute. Anything lower than that and you're going to struggle, as you probably are already aware. So how do you increase your typing speed? Well, it's easy. You just don't look at the keyboard when you type. Now, you're going to make a lot of mistakes and typos. Keep trying to correct it without looking at the keyboard, or very rarely look at the keyboard, and constantly try to look at the keyboard less, right? You'll start typing things like hello incorrectly, right? But eventually, you'll type the word correctly, and then you'll type another word correctly, and then another word, and before you know it, you can type over 100 words per minute, right? Okay, number 4, avoiding the use of efficient frameworks or SDKs. Now, back when I first became a software engineer, I used to try and reinvent the wheel a lot. Even today, I still do sometimes because I'm interested in how things work, right? But in a commercial project, a serious project, you should be using frameworks and software development kits that make sense for the task you are approaching. For example, if you're making a website, you might make it in PHP, right? However, making it in just PHP without a framework, without a PHP framework, wouldn't be the wisest idea. If you use raw PHP, you have to deal with raw PHP problems, such as potential security concerns. It'll take longer to do things in most cases. Whereas if you take the time to install a proper framework such as Laravel, you can write code a lot more efficient and get a lot done faster. And your code is a lot cleaner, which is the most important thing. Okay, number 5 on this list, and I've been guilty of this in the past, I'm ashamed to admit, is being a know-it-all. After you've been developing software for like 2 or 3 years, you might start to feel like you've learned everything and you might become a bit cocky, right? At least it happened to me, so I'm talking from my own experience here, right? the truth is, there's always more to learn when you're a software engineer. There's no end, absolutely no end to it. There's thousands of technologies worldwide. There's loads of different design patterns. There's loads of different languages. There's new languages being made every year or every other year. You know, there's far too much to know it all. There really is. So don't think that you've learnt everything, because if you think that, I promise you now that you're wrong, and you'll find that out very soon. Okay, number 6 is not understanding Git or other source control solutions. Now, you should be managing your code base efficiently by using something like Git, which will allow you to commit changes to your work and basically make an archive, a history of all the changes to your project, right? You should be using something like that. This way, if something was to go terribly wrong and some massive bug was introduced in your software and you couldn't figure out what it was, all the tests were passing, you don't know what it is, you can compare the history in your Git repository of when the software was last working and today's version. And it'll show you everything's changed since then, and you can find out exactly what went wrong. It's also a great feature because it allows people to work on the project at the same time. If two people make changes to different parts of the project, you can merge your changes automatically later on. Okay, number 7, not understanding thread safety in multi-threaded code. Now, firstly, this assumes you've written multi-threaded code before. If you haven't, you're definitely still a beginner. In a lot of situations, you won't have to write multi-threaded code. There's plenty of trades out there where you won't have to write multi-threaded code, but you should have at least done it once. Now, not understanding thread safety in multi-threaded code is very dangerous. You're going to run into concurrency problems. I remember creating server of some kind quite a while back now. The application was in Java, but anyway, it allowed multiple people to log into this server type of thing, and it wasn't like a HTTP type of thing, by the way. It was like raw socket TCP server type of thing. Anyway, I had plenty of multi-threading going on. I did not deal with synchronization issues correctly, and it led to the program getting deadlocked, threads getting stuck in loops. It was terrible, right? So thread safety is very important. I suggest you learn all about mutexes and thread safety in general, and also learn about it for the particular language you're programming in. I have a few courses on thread safety as well, by the way. Okay, number 8, code and think later. This is a bad one. If you have an idea in your head and you just go ahead and implement it without thinking, right? And I'm guilty of this. Sometimes I still do it, right? It's not a good thing to do. You need to sit down and you need to think things through. Think about how you're going to do things and then do it, right? What I like to do, I think about the start of a project, how I'm going to do the start of a project, how it's going to function, and then I'll implement that, and then I'll think about the next bit and think about how it's going to function, and then I'll implement that. That's how I do it, right? Because trying to think of the entire project as a whole from start to finish, it very rarely there's going to be no changes from design, right? You will run into problems, guaranteed. So the best thing to do is to think of the start of the project, how the start of the project is going to be, implement that, then think about how the middle part of the project is going to be, then implement that, right? That's how I do it. Now, I'll give you an example of why you should not code first and think later, right? I right now have implemented a decentralized network, right? The way I currently do it needs to be improved. Now I could go upstairs right now and just whap out some algorithm, get it done, right? But I've been thinking about this problem for 2 weeks. I won't write one line of code until I know the solution I'm going to do is the correct thing to do. And essentially the only issue with it is that the decentralized network is a bit inefficient because too much traffic's been sent around. So I've come up with an idea of grouping multiple nodes into different groups, and then the groups talk with each other, right? So it's faster. But I'm still thinking about that. I haven't gone ahead and implemented it yet because there's still potential things I need to think about. So that is think first, code later. That's what you should be doing, right? Now, number 9 is the inability to study and understand existing code solutions written by good developers. So what I mean by that is, if you are fluent in, let's just say, Java, yeah, and you look at some code from a good Java developer, right? And when I say good Java developer, I mean like somebody who's actually good, right? Other people think they're good. They've got some credibility. They're a good Java developer. If you look at their code for, let's say, I don't know, let's say you study it for like 8 or 9 hours, right? If you don't understand any of it or don't have a clue what's going on, that's a bad programmer trait. That means a few things, right? It either means you're bad at the language that the developer wrote it in, right? That's a possibility. It means you're weak in the language that developer wrote it in. Or the third option is that the technology they're developing you don't have much experience in. So for example, let's say they were making, I don't know, an artificial intelligence program, but you know nothing about artificial intelligence, but you know a heap load of other stuff about web development. Then it's going to make sense you'll struggle to understand this code, right? But anyway, number 9, I had to put that there because an inability to understand existing code means that you're lacking something regarding the project that is being worked on. Okay, number 10, and this is a very important one. Not using a debugger or not knowing how to use a debugger. Debuggers are very important, right? They were invented for a reason. If you don't know how to use one, this is a huge problem, right? And it signifies to me that's bad programmer trait, right? You should know how to use a debugger. You should know how, if you're developing in C, you should know how to compile your program with debugging symbols. You know, same with C++, you should know how to compile your program with debugging symbols. You should then know how to attach JDB or some other debugger to find out what's going on. You should know those things, right? Same for Java, you should know how to attach a debugger there, right? You should. If you don't understand debuggers, you don't understand how to step through code in a debugger, you don't understand how to view memory that you're debugging, this is a problem. You need to learn how to do this. It'll make your life so much easier in the future. So they are the 10 bad programming traits I could think of. I tried to use examples that have impacted my life for me personally. Mistakes I've made throughout my 13 plus years experience. Granted, a lot of these things happened when I was a lot younger, when I was first doing this. Back in my 2 to 3 years of programming experience. That's where most of these problems happened for me personally. Although the code and think later one is a difficult one sometimes, because sometimes you're so sure you just want to get on the keyboard, right? But just take a step back and think about the problem properly before you implement it. Think to yourself, how do I solve this? And what is the problem I'm trying to solve? And then think about a way to solve it, right? And chances are you might think you thought of the right solution. You might code it and figure out to yourself, oh, wait a minute, that was a terrible implementation. And you've got to go back and change it. That's completely normal. That's fine. These things happen, right? Just as long as you think first and then code. If you've made a mistake after that, don't worry. Just go back, correct it, right? The whole point of number 8, code and think later, is just to, the reason I mentioned that is because some people, they don't care about how something's implemented. They just want a working solution. That's the mindset you shouldn't have, which is why it's on that list. As long as you're trying to think and solve a problem and not rush it to a solution, then you're on the right track. Alright, that's it. Hope you enjoyed this video. Let me know your comments. Let me know if you think I've missed anything. And let me know if you think I should do a video like this again. Alright, take care guys. Bye.